Okay, so for our last section, we're going to be talking about parallel lines and perpendicular lines, which are completely opposite of each other. So let's talk about what each are. Hopefully you've heard these words before, but let's define them. So parallel lines are drawn kind of like this, and parallel lines never touch, kind of like train tracks. So those lines are never going to meet, they're never going to touch each other. So the relationship of their slopes, so if we were to find the slope of this line and the slope of this line, since they never touch, slopes of parallel lines are going to be exactly the same. So if the slope of this line is 2, then the slope of this line has to be 2. That's why they never touch. So perpendicular is completely opposite. Perpendicular symbol looks like this, because these lines are definitely going to cross, and they're going to cross at a 90-degree angle or a right angle. So two lines that cross at 90 degrees or a right angle. So the slope of these lines are going to be not the same. They're going to be opposite of each other. And it's going to be the reciprocal. So you might be asking, what the heck does that mean? Okay, so opposite means if one is a positive, the other one's going to be a negative. That's opposite. Reciprocal means that you're just going to flip it around. So if one is 1/2, the other one would be 2 or 2/1. So the lines, the slope of those lines are going to be opposite and the reciprocal. All right, so let's see if we can identify. That's our first job here today. So we're going to find the slopes of each line, and we're going to determine if they're parallel, perpendicular, or maybe they're nothing. So the first two examples are written in slope-intercept form. So y, and all of these are going to be written like this, y equals mx plus b. So if you remember that format, you should know that the m, or the slope, is always right next to the x. So I have my two m's here. So the slope of my first line is -3, and the slope of my second line is -1/3. So let's ask ourselves what this is. So let's see if they're parallel. If they were parallel, the slopes would be exactly the same. So are these parallel? No, they're not exactly the same. So maybe they're perpendicular. So if they were perpendicular, they would be opposite and reciprocal. So let's see, are they opposite? Nope, they're both negative. So these right away cannot be anything. They're not parallel, they're not perpendicular, so we're going to write neither. These are just two regular old lines on a graph. Let's look at these. So right away they're in slope-intercept form. So I'm going to point out what my slope is in each. So the slope of the first line is -1/2, and the slope of the second line is -1/2. All right, so let's ask ourselves some questions here. Are the slopes the same? Are they exactly the same? -1/2, -1/2? Yes, they are. So these two lines are parallel, and they're never going to meet. Same slopes. Okay, we'll keep going here. If you know what you're doing, you can keep going without me. All right, so slope of the first line is 2/5. Slope of the second line is -5/2. So let's ask ourselves some questions. Are they exactly the same? Nope, they're not. So they can't be parallel. Are they opposite? One positive, one negative. Yes, they are. Positive, negative. Now, are they flipped, reciprocal? 2/5, 5/2? Yes, they are. So it meets all the requirements of perpendicular lines. All right, last one. Slope of the first line is 1/4. Slope of the second line is, this one's written a little weird. This one is not in slope-intercept form. Y is not by itself. So what we're going to have to do is get it by itself. So just kind of get rid of this -4x on both sides. So we're left with y equals negative 4x plus 7. So I just moved this 4 to the other side. So my slope now is right by the x, so negative 4. So the slope of this line is negative 4. Okay, so are they exactly the same? No, so they're not parallel. Are they opposite? One positive, one negative? Yes, they are. And are they flipped around? 1 over 4, 4 over 1? Yes, they are. So these two are perpendicular lines. Okay. Any more? Let's look. Yes, there's a couple more here. Let's try one of these and then we'll do the rest together. Okay, so find the equation of a line that is parallel to this line and goes through the point. Okay, and it looks like we have to graph it. So parallel, that's a key word. If these lines are going to be parallel, they're going to have exactly the same slope. So the slope of our line has to be the same. So the slope of our line is going to be 2. We also have a point. So we have 4 and 3. So we're going to do point slope form. So y minus 3 equals 2x minus rx. And it has to be in slope intercept form. So we're just going to convert it or change it like we're used to. So we're going to have y minus 3 equals 2x minus 8. And we're going to do the opposite, add 3, add 3. So y equals 2x minus 5. So there's our equation. We can graph it two ways. We can graph it with this information, or we can graph it with this information. So let's try to graph it from here. So I'm going to start at my b, and I'm going to move with my m. So we're going to go down 5, 1, 2, 3, 4, 5. And we're going to have our slope is 2 over 1. So there's your line. All right, let's try this one together in class. If you want to try it on your own, go for it, but just be careful. This one is now perpendicular.